Good afternoon. How's everyone doing? I'm going to give a minute here so they can change rooms. This has been some great talks, huh? Great. So I'm actually here to talk to you today about one of the most exciting and fast-moving parts of modern technology, monitoring serverless applications. Little background on me. I've been at New Relic about 3.5 years in the product org. I've been focused on APM most of my time here at New Relic, and I live in Portland, Oregon. And it's been really exciting to be back here in Australia, spending time with all of you, talking with our customers about their problems and the new things that they're doing, and reconnecting with the team. I'm super proud to be here representing a lot of hard work and a lot of activity that's done by our two engineering teams located in Portland and Barcelona. They do a really amazing job of building out the new capabilities that you all need for the new things that you're doing with the cloud, containers, and serverless. And it's not always easy for them. There's a 9-hour difference between these two teams, and it can lead to some challenges that maybe some of you are familiar with. I'm going to try to bring out an example of that later on in the talk. I just want to pause for one moment and give a special shout out to one of our software engineers, Javi Imbernon. He's located in the Barcelona team, and he actually built this talk and delivered it for the first time at FutureStack San Francisco a couple weeks ago, so I'm here on his behalf. This is actually a picture of part of the team from Barcelona that builds our cloud integrations, part of the New Relic infrastructure team. That's Javi over there on the left. I want to draw your attention to one thing in the picture. You see the looks on their faces? That frustration and annoyance can only come from debugging a serverless application. And I mean, the thing is, this is a really amazing group of engineers. They're really, really great. But monitoring serverless applications, it's really, really hard. I should probably, though, start at the beginning and give a little context around what we mean when we say serverless. So when we hear serverless, obviously, most of us think about AWS LAMBDA. It's the first thing that leaps to mind. But serverless is a lot more than just AWS LAMBDA. There's an entire ecosystem around serverless. There's AWS Kinesis, DynamoDB, S3. These are all serverless concepts. And really understanding and monitoring and making sure that your full end-to-end serverless applications are healthy and running really requires monitoring not just Lambda, but monitoring everything around it. And so the good news here is that New Relic over the past year and a half or so, we've invested heavily in monitoring cloud services and serverless in particular. All those services that I mentioned before are services that we monitor with our integrations here in New Relic. And so, for example, what you see here is, for any of you that are using Lambda and our Lambda integration now, you'll recognize this. This is a dashboard that you get right out of the box from connecting your AWS account to New Relic and using the AWS Lambda integration. You get a dashboard like this. And what it shows different kinds of configuration data and aggregated metrics that we fetch from the AWS APIs. And the same is true, this is just one example, the same is true for all of our other cloud integrations. But this is not really enough for monitoring serverless applications because it's really all about context. As I said before, it's not enough just to monitor your Lambdas. You have to monitor the entire ecosystem around it. And it can get really, really complex. So what I'm going to do right now is I'm going to walk through a couple examples of some typical workloads so that we can start to understand what a typical serverless application would look like and then how it can get more and more complex. So here's a pretty straightforward one. It's a simple web application built in AWS, and HTTP requests are handled through the API gateway endpoint. It invokes a Lambda function which processes the request, and then it gets and puts some data into DynamoDB. It's pretty simple, pretty straightforward. Let's look at another example. So this is an example, in this case, of a modern, high-throughput streaming data collection and integration system. And so just like with the other one, it follows the same kind of process. We hit API gateway, it goes to a Lambda function, gets invoked to do some processing, and it feeds it into a Kinesis data stream. And then that data gets processed asynchronously. So then what happens is we write another Lambda function, and that Lambda function does some more processing of the data. It aggregates it together, and maybe it puts it into an S3 bucket. And it can get much more complex from there. We could potentially write another Lambda function to consume from the same Kinesis data stream to do a different kind of workload. Or we could write yet another Lambda function to pull data out of that S3 bucket and take that data and use it for another purpose. It gets more and more complex. There's more and more entities to monitor and keep track of, and there's more and more moving pieces. So you can see why I'm saying it's really all about the context. It's not enough to know what's going on within an individual function. You have to know what's going on all around that function. So it's about visibility into all the discrete different systems and services that you're using, and understanding that context is really essential for observability of your system. So now, we know at New Relic that we have a lot more work to do in this space as Lambda and functions become a much more integral part of these serverless systems. It's really hard to explore context of that full system in a single dashboard with aggregated metrics. So we've been asking ourselves, how can we leverage all the data that we use in New Relic today and that we make available to you today to give you a better experience? So I didn't realize Sean's talk would go into this so much, but this is a perfect segue because about 4 years ago, as our customers were starting to move to Docker containers, we were actually one of the first companies to start deploying large production, high throughput workloads into production using Docker. And so our customers were on that same journey at the same time. We shared a lot of the pain, and we had similar needs. Then after that, we started building out, as our customers started moving to the cloud, we helped them with that journey, building out cloud integrations and creating better visibility. We're all on that same journey now with serverless, and really most of us are at the beginning of that journey. So as any good agile software company would do at the beginning of a journey like that, we started with an experiment. And so some months back, one of our engineering teams started experimenting with what would it mean to begin instrumenting Lambda functions. And we noticed 3 really important pieces of context when we started off on that journey. So first, we realized that we could get the source of the invocation by looking at the parameters around the Lambda functions in the AWS API. And this would, for example, tell us that a particular function was consuming from a particular Kinesis stream. We were also able to determine what was going on inside that function. We could get duration of how long the function ran, and tracebacks, and errors, and CPU, and memory. Sorry, and just a memory. The third piece of context that we were able to grab was using the AWS SDK, we could see what other functions within the entire serverless application were being invoked. And so you can start to see this is actually pretty similar in many ways to what you would expect from the applications that you're monitoring right now with APM, to be able to see a holistic, to have holistic observability of what's going on within your application. So the next thing that we've done is that then we've pulled all that context all into one place. So we've created a dashboard utilizing all of this data. And you can see if you look into this dashboard here, we can show the source of the invocations for individual function calls, like for example in this case that we can see that we're consuming from this Kinesis stream. We can show for the individual functions the tracebacks and all the details, so you can know exactly what happened with that particular Lambda invocation. And then here's another example of where you can see the other AWS services that are being called by these Lambda functions. In this case, a put record from in this Kinesis stream. So that's pretty cool. But we need to take one really, really important thing into account, and that's that performance is critical. Serverless architecture is very different from what we're used to building when we're used to building traditional applications. And performance is always important with applications. But in this case, there's some things to take into account. An extra 100 milliseconds of extra execution could cost you thousands of dollars per year in your AWS bill. So let's take a look at an example from one of our biggest customers to get a better sense of what I'm talking about here. So for this customer, they've got about 9,000 invocations per minute in all the Lambda functions that they're using. So if we use the standard approach for collecting data with an agent that New Relic uses now, where there's an HTTP call and you send out that monitoring data, and then you look at the typical configuration for this customer where most of their functions are set up with 1 gigabyte of memory. What that ends up being with the extra 100 milliseconds of execution time, that ends up being about $8,000 a year additional on their AWS bill. And that's not accounting for the delay in the response of the Lambda function while waiting for it to send that data out. So we can't afford that, and we need to take a different approach. So the approach that we've taken is that first, we include the instrumentation in the source code of the function. And what we do is we use the framework instrumentation that you're used to seeing in APM now, break it out into pieces, and be able to give you that automatic framework instrumentation, whether you're using Python or Node or Java or whatever language you happen to be choosing to use for your Lambdas. And then what we do is we emit all of that instrumentation into the CloudWatch logs. So this is the most native and performant way to get this kind of telemetry out of Lambda functions. And everything that gets written as standard output can go right into the CloudWatch log stream. So then what we do is we deploy another Lambda function that we call the log ingestion function. And what this does is that behind the scenes, it leverages capabilities that AWS has for minimizing the number of invocations with batching and optimizing it so that we can send all of that data to the New Relic ingestion pipeline. And what we found is that AWS sort of handles that optimization behind the scenes so that we minimize the cost and the load. And then what happens when it gets to New Relic ingestion pipeline is that's where, in our SaaS platform, we add all the metadata that you need to do the cross-correlation and the connection of data across all of the entities. And we create all the relationships that need to exist for that Lambda function to all the other things that we monitor within New Relic. And then we make it available in NRDB. And once it's available in NRDB, it's available to you for alerts and for dashboards, and for us to build new curated experiences around these serverless applications. So what's next? So right now we have a solution for instrumenting Lambda functions in a performant way. And we have a way of ingesting all of that monitoring data into our system. And we've been working to validate these approaches with some of our customers that are big early adopters of Lambda for production workloads. But even this is still enough because, as we've talked about, it's really all about the context. So a dashboard is not always the best way for deeply understanding what's going on within these applications. It's a really good way for seeing on the outside at a high level what's happening, but it's not really great for drilling in and finding problems quickly. So we're working to build a new set of experiences for exploring all of this data in a meaningful way. We're still in the early stages of this, but I'm going to show you how we imagine all of this to be working in our solutions when we release them. So I'm going to walk you through an example. So Imagine it's 1:30 in the morning, and you get an alert on a Lambda function that you've deployed into production. And you get up, and the first place that you start is with a relationship map. And you can see that this Lambda function is talking to a few things. It's interacting with the DynamoDB table, and that looks healthy. And it's interacting with this Kinesis stream, and that looks a little less healthy. So let's go a little bit deeper. So when we start to drill into the Lambda function, we're going to start to surface to you data about what's going on with that particular Lambda function. And as you can see in this case, the throughput stayed steady for our Lambda function, but our error rate went up to 100%. It started completely failing. And we can see down here the individual invocations of the distribution of some of the individual invocations. So let's drill into one of those invocations. So then we're going to show you a waterfall view where you can see all the things that happened within the life cycle of that particular end-to-end trace. So you can see with this Lambda function, it does a put item to DynamoDB to a table called random table, and that took 3 seconds, and it worked. And maybe that's what you expect, and maybe it's what you don't expect in terms of timing, but that doesn't seem to be the source of the problem. Then we can see that our put records to Kinesis are failing. Now, the good news is we're monitoring that Kinesis stream, so let's drill into that a little bit further. So we can then see two really important pieces of context here. We can see that we can see the API gateway invocation, the source of the invocation. That's not really important in this case. But we can also see up on the right that we can see that we have a provision throughput exception. And so it looks like we're getting throttling errors. So let's drill in even further to that Kinesis stream. So now we can see that the throughput on that Kinesis stream went up and up and up, and that we can see right around the same time our alert came off, we also see it escalating, and then we see us getting to the throttling error. So we're exhausting the write quota for this Kinesis stream. We can see that the reads are doing fine, but the writes were escalating and then throttling up. So the question becomes, why are we exhausting the write quota for this Kinesis stream? So let's drill in even further into what's going on there. So the relationship map is now focused on the Kinesis stream, and we can see that our function over on the left, but we can also see this other function that's calling the Kinesis stream, and it's called Bill's load test, and that looks unhealthy too. So that's starting to get pretty suspicious. So when we drill into that, then we can see that at 1:30 a.m., this Lambda function starts to ramp up its calls, and right about the same time that we start to see our throttling issues over on our Lambda function. So now it's becoming pretty clear. So at 1:30 in the morning, Barcelona time, Bill in Portland, 4:30 in the afternoon, started a load test, and that load test started to exhaust the write limits on that Kinesis stream. And when we ran out of writes, our entire Lambda function stopped working. So we've been able to find the root cause of the problem in just a couple minutes by moving around through the context that we already collect in New Relic. And we've been able to explore all of the context around it so that we can figure out the problem. I think that this is really fascinating. I had not seen Pratik's talk. How many people were here for Pratik's talk? So didn't he say that somebody had started a load test and brought down and caused an incident? This is a very real life example, and I think it's pretty amazing how frequent that can happen in our distributed world. Really interesting. So. And it's really important to be able to gather all this context together in one place to identify and solve problems. We're really proud of the progress the team's made so far in building out these capabilities. And we've really validated that we have all the things that we need to be able to lead in this new era of monitoring serverless applications. We have a lot more work to do, and that work is going on right now, and we're really looking forward to bringing all these capabilities to every one of our customers in the coming months. At the rate we see you all adopting serverless applications, we know we can't move fast enough, and we're really focused on it because we know that for you all, it's really all about the context. Thanks very much for listening. Thanks for coming.